Okay, we are going through the Further Maths mock paper, starting with question 1, nice straightforward expanding brackets. So expanding the brackets here, we're going to do 4 times the 2x, 4 times the 3, 2 times the x, and then 2 times the negative 7. So 4 times 2x is 8x, 4 times 3 is 12, 2 times x is 2x, and 2 times minus 7 is minus 14. Simplifying this, we have got 10x and then minus 2. Next one, expanding this one, we've got to do the m cubed times m and then the m cubed times 2. So m cubed times m is m to the power of 4, and then that's plus 2m cubed. 1c, we've got to make d the subject to this to solve this. First thing we can do is we can times by the 4 there to get rid of it on the denominator here. And that's going to give us 9 minus 2d on this side, and then times it by 4 on the right hand side will give us 4 minus 4d. And then grouping together the d's, getting the numbers to the other side, we add on the 4d here, that's going to give us 2d on the left hand side, and then we can do 4 take away 9, it's going to give us minus 5. Then we can divide by 2 to get d, so that's minus 5 over 2, that's fine for our answer as a fraction, or as a decimal we can have minus 2.5. Question 2, we are looking at this sequence here. We want to look at the n plus 1 term. So that is going to be, instead of having n in our term, we need to put in n plus 1. So that is 4 brackets n plus 1, and then minus the 10 that we've got there. Expanding this out gives us 4n plus 4 minus 10, and then simplifying that down is 4n minus 6 as required. Next, we want to prove the sum of any two consecutive terms of the sequence is divisible by 8. So that means we're going to have the n term, the one we've got at the top, and then the m plus 1 term, which we've worked out in part A. So we're doing the sum of those, so we're going to add those together. So that's going to be 4n minus 10 plus on 4n minus 6. Simplifying that gives us 8n, take away 16, and then factorizing we can take out 8. So that's n minus 2 in the bracket. Then this factor of 8 tells us it's divisible by 8. Okay, divisible by 8. For a different sequence, we now have this. We want to say whether 1 can be a sequence. One way to prove this, or to show that it can't, is to put the nth term of the sequence equal to 1, and then solve that and see what n equals. So if we times by the n plus 5, that's going to give us 3n equals n plus 5. Take away n gives us 2n equals 5, and then n equals 2.5. N has to be an integer for this to be a solution, because n is our term position. So as n is not an integer, 1 is not a term. Then finally we want to find the limiting value of this sequence. So we're looking at what happens as n tends towards infinity, very large values of n. So what we get is this plus 5 on the denominator. As n gets very, very big, that has a very insignificant difference to this fraction. So what we can say is 3n over n plus 5, it's going to tend towards 3n over n as n tends towards infinity. So that plus 5 is irrelevant there. Then we can simplify this down, which is just 3, as the n's are cancelling out. So the limiting value of the sequence is just 3. For the next question, we are doing a circle theorems proof. So we need to prove that the angle BOC is 90. So this one here. We've got x here and x there, and then we need to start filling in other values to see what we get. So straight away, because these two lines are both going to the center and to the circumference, they must both be the radii, which means we have an isosceles triangle, so that angle has to be x. So we need to write that down. Angle OCB equals x, as OBC, the triangle there, is isosceles. Okay, we can then use the triangle there to work out the angle BOC in terms of x. So we can say angle BOC equals 180 minus 2x, and that is because the angles in a triangle add up to 180. Okay, so we've got our angle is 180 minus 2x. Then we want to look at the relationship between this angle here and the angle up at the top there. So we can say that angle BOC, the one we've worked out, is also equal to 2x. And that's from our circle theorem that says the angle at the center is twice the angle at the circumference. Is twice angle at circumference. Okay, so we've got two different versions for this angle. So we can say that 2x equals 180 minus 2x. Then solving this, add on the 2x there, it's going to give us 4x equals 180. Divide by 4 gives us x equals 45. But the angle we have is BOC equals 2x. So angle BOC equals 2 times 45 equals 90, which is what we want to prove. Question 4 is to do with this cylinder and the volume of water in it. So y is the volume that we have, and we're going to show that it is equal to this equation. So we've got the radius and we've got the height or the depth here, and we know that the formula for the volume is 1/3 pi r squared h. What we have is that the r is x in this case and the height is 3x. So we can say y equals 1/3 pi times x squared for the radius, and then times by 3x for the height. Simplifying this, the third here and the 3 are going to cancel to give 1, which just leaves us with pi and then x cubed from the x squared and x. Part B, finding dy by dx, so that is differentiating the term we have here. So when we're differentiating, we're going to be looking at the power on x. So in this case we have 3. What we do is that 3 is multiplied by it, and then we have to take 1 off that power of the x. So that gives us 3x squared, not forgetting our pi term, still a multiple there, so that's still going to remain. Part C, we're going to be finding the rate of change at a specific x value. The rate of change is our dy by dx, so that's what we found in part B, but we're now doing it at x equals 5. So what we need to do is sub x equals 5 into our 3 pi x squared. So that's going to give us 3 pi times 5 squared. 5 squared is 25, times by the 3 is 75 pi. And our answer in terms of pi as required. Right, solving inequalities. We'd solve this in the same way as if it was an equal sign here, so moving our y's to one side and the other numbers to the other side. So taking away 2y here is going to give us 3y, adding on the 4 is going to give us 10, and with our inequality in the middle. Next thing we can do is divide by 3, so that is going to give us y is less than 10 over 3. Leaving our answer as a fraction is good here, or we could write this as 3.3 recurring, but definitely preferring the fraction for that. Part B, slightly trickier inequality in that this is a quadratic. So quadratics, as we know, have more than one solution, 2 solutions often. So we want to find out what those solutions are. The way we do that is by factorizing. So if we factorize this, we get x minus 3 and then x plus 1. So minus 3 times 1 is the minus 3 there. Minus 3 plus 1 is the minus 2 we need there. And we want this to be bigger or equal to 0. Now if we think about what this graph looks like, these two values tell us the roots of this equation. So it crosses through at 3 and it crosses through at negative 1. So our graph looks like that. Now what we've got is for this to be greater than 0. So on our graph we're only going to be interested in the parts of the graph where it is above the x-axis, where it is positive. So looking at this, we can have any values going off that way from negative 1, then any values going off that way from the 3. So we get two separate inequalities as these sides don't join up. We can have x is less than or equal to minus 1, or x is greater than or equal to 3. Finding the stationary points of an equation, what we need to do there is differentiate to find the gradient. So dy by dx, differentiating our x cubed is going to give us 3x squared. 3 comes to the front and then taking 1 off the power. Differentiating minus 12x is going to give us just minus 12 there. 1 off the power times by that leaves the negative 12, and then taking 1 off gives us x to the 0, which is just 1, so just the negative 12 there. For our stationary points, we want this to equal 0. So 3x squared minus 12 equals 0. And we can solve that to find out what x is. So this is 3x squared equals 12. Divided by 3 is x squared equals 4. And then solving that, taking the square root gives us plus or minus 2. So there's two stationary points here. One when x is plus 2 and one when x is minus 2. We want the point, so we need to find the y value as well. So when x equals 2, subbing in 2 into our equation, 2 cubed is 8, and then minus 2 times 12 would be minus 24, so 8 minus 24 is minus 16. And then when x equals minus 2, minus 2 cubed is minus 8, and then we've got minus 12 times minus 2, so that will be plus 24 there. Minus 8 plus 24 is positive 16. So our two stationary points are at 2, negative 16, and then negative 2, 16. Sketching the curve of this, so we've got our two stationary points, one at negative 2, 16, it's going to be up there somewhere, one at 2, negative 16, down there somewhere, and this is a cubic shape, so it's going to start down low, go up to our stationary point, come down, this one will go through 0, and then back up, hopefully slightly straighter than that, that is not great. So going through 0, these are our stationary points, negative 2, 16, and then 2, negative 16. Other points we should label, just to make this a good, clear sketch with all points, interesting points labeled, is the roots of this equation. So we get the roots by looking at the solutions to our equation. So if we factorize this, what we get is y equals x, and then x squared minus 12. The x here tells us that it crosses through at 0, that is our first solution, and it's from this x squared minus 12 that the other solutions come from. So what we need to do is set that equal to 0. So x squared minus 12 equals 0. that means x squared equals 12. So x equals plus or minus the square root of 12. So that is these two values. That's going to be minus root 12, and this one's going to be plus root 12. We could simplify that because we know 4 goes into this as well, so we could write that as the square root of 4 times the square root of 3. Square root of 4 is 2, so this is 2 root 3. This is our negative one, and this equals 2 root 3, positive on that side. Final question on the paper, we are looking at this cubic equation, and we are told a couple of solutions of this. So we can use the factor theorem to sub in these values into this and then work out a and b. So when x equals 1, what we're going to get is 1 cubed, which is 1, minus 1 squared, which is 1, plus 1a, plus b equals 0. Simplifying that down gives us a plus b equals 0. Subbing in 2 is going to give us 8, which is 2 cubed, then minus 4, 2 squared, plus 2a plus b equals 0. Simplifying that is going to give us 2a plus b equals minus 4. So what we have here is a couple of simultaneous equations. If we do the second one, take away the first one, that is going to give us a, and then b take away b is 0, equals minus 4. So we get a equals minus 4, and then we can work out b as well. So subbing this into the top one will give us minus 4 plus b equals 0, which gives us b equals 4. So what we have is the two values for a and b. So our cubic equation here is x cubed minus x squared plus, not plus, sorry, that should be a minus, minus 4a plus 4, which is our b value, equals 0. What we also have is that these two are solutions. So if they, because they're solutions, they must be some of the brackets as well. And then what we're trying to work out is that third value in the brackets. It's going to factorize the 3 brackets because it's a cubic. We've taken the negatives here because these are the factorized brackets rather than the solution, so they're going to be negatives here. Then we need to think about what this expands to and how we can get it to expand to the above here. Sorry, that should be an x there. So just thinking about this last term here, that plus 4 on the end, what we have is that can only come from multiplying the numbers in the brackets. So what we have is minus 1 times minus 2 times by our value k is going to equal 4. The only value that is going to work for this is, well, if we simplify it, we get 2k equals 4, so k equals 2. So what we've worked out is this last bracket is x plus 2, and that is one of our factors. So the solution that we get from this is x equals minus 2.